Hey, fourth grade All-Stars. Today we're going to look at simplifying your area model. An area model is a great way to organize your partial products. It's not always the most efficient way of solving these multiplication expressions, but as we're getting into more complicated partial products and multiplication expressions, it really helps you attend to Precision Math Practice 6. And today we're going to look at a little trick or strategy how you can simplify your area model when you are multiplying multiples of 10. So as a quick review, let's just remember what a multiple of 10 is. So a multiple of 10 are any of those numbers that you are multiplying factors that have a factor of 10 in it. And what I mean by that is 10, 100, 1000, 20, 200, 2 million, 2 billion. Any number that ends in those zeros is a factor of 10. Any number that you would multiply by 10, like if you took 2 and you multiply by 10, you'd have 20. If you took 17 and you multiply it by 100, you'd have 1,700. So when you have these numbers that end in 0, you can simplify your area model. So first, let's just look at how will we set up an area model for maybe the problem 21, 21 times 18. So when we are setting up our area model, when we're doing the factors of 21 and 18, and we're trying to find the product, we look at how many digits are in each factor. And we know there's 2 in this one and 2 in this one. So my square, my rectangle, needs to have a total of 4 boxes, because 1, 2, 3, 4. And we would know that we would want to break these numbers up into expanded form. So we may be looking at 20 and 1, 10 and 8, because 20 and 1 is 21, 10 and 8 is 18, and this gives us a great way of using our knowledge of extended facts, to multiply. We would do 20 times 10, we would do 10 times 1, because we're just pairing them up, 20 times 8, and 1 times 8. And we would solve all those factors, like 200, 160, 10, and 8, and we would add them all up together to find our final product. This can look a little different when we have a multiple of 10. You can reduce the amount of boxes you need because you're not going to have to break up that into expanded form, because you're not going to do, I'll give you an example, 20. You're not going to do 20 and 0. And this is what I mean by that. So let's take a look. We know now in this factor we have 1, 2, 3, 4. We should have 4 boxes, correct? However, it wouldn't make sense to have a 20 and a 0, a 10 and an 8, because we know the 0 property of multiplication tells me any number times 0 equals 0. The 0 property would tell me any number times 0 equals 0. So you would be getting zeros in these boxes, and it's just serving a placeholder. So what you can do when you have these multiples of 10, or these numbers that end in 0, you could just simplify your area model to only have 2 boxes. So when I look at these 2 boxes, I know that 20 times 10 is 200, 20 times 8 is 160, 20 times 18 would be 360. Let's try another one. What if we did 50 times 24? So typically you would draw your 4 boxes in your area model. I'm going to just do 2, since I have a multiple of 10, a number ending in a 0, because that's just 5 times 10, right? So I have my 50 here, and then my 20 and my 4. 50 times 20, 5 times 2 is 10. Add my 2 zeros to my extended fact, that's 1,000. 5 times 4 is 20. Add my zeros, 200. I have 1,200 as my total for my partial products. So with this method, you are looking at the same process, but instead of multiple boxes, because you don't need to do the zero multiplication, you're simplifying those boxes into just 2 boxes. Later this week, I'm going to teach you the standard algorithm for multiplication. And I think that's a good, solid, easy strategy to use. But I would like you to try to practice either with area models or partial products. So I'm going to review partial products one more time. They call this the expanded algorithm in your book. I like this as my go-to multiplication method. So let's look at the numbers 28 times 20. And what you do with partial products is you want to make sure you write down all of those partial products first and then solve. That way you know you've gotten every step, because that's the one mistake that a lot of people that I've worked with over the years have made with this method, is that they forget to do all the steps. It's not that they don't understand it, they just forget to do a step. And with the standard algorithm, it's hard to forget that step because you're working from right to left. But we'll talk about that later this week. So let's look. We are going to multiply my ones from one factor by my ones in another, my ones by a 10. So we're going to go here and here. And then we're also going to go here. We're going to multiply that. We're going to multiply that. It looks a little confusing with those arrows, but let's look at it step by step. 0 times 8, 0 times 2. Now remember, this isn't a 2. This is a 2 tens. 2 tens is 20. 20 times 8. 20 times 20. And now we just solve. 0 times 8 is 0. 0 times 2 is 0. 20 times 8 is, 2 times 8 is 16. Add my zeros, 160. 2 times 2 is 4. Add my 2 zeros is 400. If you can't do that mentally, if you can't figure out 400 plus 160 is 560, my suggestion to you would be to rewrite it as an addition problem using the largest number, the greatest number on top. We don't need these zeros because we know 0 plus 0 is going to equal 0. Any number plus 0 is going to equal that number. 0, 6, 5. And that is the partial products. They call this the extended or expanded algorithm, not extended. Expanded algorithm. So today, your mission is to just get the correct product or answer to the multiplication problem. I don't care how you get there. You know, your map might take you in the direction of the expanded algorithm. Can't write today, guys. Your journey or your map might use an area model. But if you're using an area model today, one thing I would like you to try, I like you to try to simplify it when you are working with powers of 10. So think about changing those boxes like we did with the first example. All right, you cool cat mathematicians, good luck today. I think you can nail this.